Hey, good morning all. I'm getting ready here to jump into this topic of sine and cosine function graphs. I will give you a quick warning that this is a long topic, so you'll probably want to pace yourself on it. Make sure you stop and take notes and make sure you're understanding everything I say, even if you have to go back and repeat. And if you need to stop and break this up into 2 days, that's perfectly acceptable. Those that are doing the video feedback, just in the in it somewhere put I stopped after minute whatever as far as you got because you wanted to understand it completely. So you might want to break it into 2 days. So here we go. We're going to talk about graphing now sine and cosine functions. So what that means is that you're going to be taking sine of a value, and that certain value in radians is going to be on our x-axis, and on our y-axis we're going to have what you get for the sine or the cosine or whatever type of graph that you're making. These functions are periodic because remember they're based on the unit circle. So what happens is that they begin to repeat and repeat and repeat every time you go around the unit circle. So when we're graphing the values, you have a type of graph that repeats as you go along, and we will begin to see that and hopefully make that clear to you. So one complete cycle in the unit circle actually is going around the circle one time, and then you've run through all of the sine values or the cosine values as you go. So here's our unit circle, just to remind you. And as you go around it, like you're at 0 radians here and you go through pi over 2 radians, you go through pi radians and 3 pi over 2. When you come back to here, you'd be at 2 pi radians, which would be one complete trip around the circle and one complete set of these values, which are your sine values as you go around and around and around. So what I want to do is I want to take a little bit of time here and go through your sine values and remind you where they come from. Okay, so if we're making on our x-axis, we have all of these values as we're going around the unit circle. Remember, our sine values come from the y coordinate in these ordered pairs, different than this y, although for sine, because sine actually equals, sine would always be the y value. We'll do something similar for cosine, where we'll be looking at the x values, but let's start with the sine values. So as we go around, we get 0 for 1, 0. We get a half, square root of 2 over 2, then square root of 3 over 2, then 1, then square root of 3 over 2, and then square root of 2 over 2 goes with 3 pi over 4. 5 pi over 6, we get a half. At pi, you get 0. At 7 pi over 6, you get negative a half. And so on and so on and so on. As you go around, we have a list of values that includes all of this part of your ordered pairs, as we found when we were finding the sine values by using the unit circle before. So what we need to think about now is what that would look like if we were to graph it so that your x-axis is not the x-coordinate in the unit circle, but if your x-axis is actually these values right here in terms of pi, so you have a radian axis, and then your y value is your actual numbers that you get as you go round and round the unit circle. Okay, so let's take a look at here. I'm going to start off. Now, whenever you're graphing sine functions or cosine functions, there are some key points that everyone who's looking at a graph should be looking for. First one is the places where you've got zeros. In other words, the places where there's going to be a change in that graph. Now, when we get around to shifting the graphs, when we change some of the things that go with these, you know from your past experience in Algebra 2, certain graphs will move up, down, left, right, and all these. But there are some anchor points, okay? So our anchor points here, first of all, are the ones where you have zeros in your y coordinates. So our x coordinates are 0, pi, 2 pi, as you go in one complete circuit around the unit circle. And these are the ones that have zeros. They are very, very important points. The other important points as you're trying to sketch out a general shape from a graph will be the ones at pi over 2 and 3 pi over 2. Because these spots on the graph are going to give you your general shape when you're starting to sketch it out, when you are asked to sketch a sine curve or a cosine curve by hand. I'll be specifically looking for certain things. Like, for example, at pi over 2 we get 1, and at 3 pi over 2 we get negative 1. And if you'll notice these values, and if we were to make these into decimals, we'll have a half thrown in there at pi over 6. We'll have square root of 2 over 2, which would come out to be right about here. But the thing is that these values, when you're thinking about the unit circle that come from here and from here, those are basically the limits. That's going to be as big as the y values get. I want you to be thinking the y values are actually the values that are going from here to here. So you're thinking about if you were to take a piece and take it and think about where that would be on a graph, you would be looking at the lengths of these pieces, and they're never going to be longer than 1 when you're thinking about them coming up like that. So back to here, at pi over 2 we have 1, and at 3 pi over 2 we have negative 1. So these points right here are all the very important points when you're graphing. Now, we don't just connect the dots in straight lines. Okay, for a sine curve, what ends up happening is when you graph the other points, like at pi over 6 and 5 pi over 6, what we notice is those values are at a half. And if we notice that 7 pi over 6 and 11 pi over 6, those values are negative a half, all of a sudden what we begin to see is a pattern where you've got kind of a curve going on, but not an exact straight line. So what you could do if you wanted to is you could fill in all of the other values. I've just filled out some of them because it's enough to show that a sine curve almost looks like the top of a circle and a bottom of a circle that are back to back like this. A nice curve definitely does not straighten out into points. You're not having hard points of turnaround here. It doesn't bounce back up from here. But what would happen would be, because after you get to 2 pi, if you went ahead and you moved yourself around again, what you would find is that these values would be repeating themselves, because this really is 0 and 2 pi are really the same place on your unit circle. But then as you go around again, every single one of these values is going to repeat as you go another pi over 2, and as you go another pi, and on and on and on. And what we find is 5 pi over 2, that's another half beyond, so we get this point repeated. 3 pi, well, that's just around the circle one complete time from pi, so that repeats. So the whole thing repeats, and the whole thing repeats on the the negative side too if you were going backwards. So once you have a basic one period of a sine curve, that curve goes on and on and on and on. You have applications for that in music and all different various things where you've got any kind of wave motion happening. And so it can be used in many different forms of study. So when you're graphing these, you want to think about what values make sense for your domain and for your range. The domain is on and on and on forever, because you can keep going around and around and around that unit circle forever and ever and ever and ever and continue to get values for y, continue to get sine values over and over and over and over again, because they're always going to have the value that you can calculate. However, the range, though, it never goes any higher than 1, and it never goes lower than -1. 1 is a value and -1 is a value, but it never bounces any higher or lower than those two numbers. So the range is from -1 to +1 because it's bouncing around in between. Now it is important that when you are making your graph, it is super important that you make sure that when you're showing your points, you're showing these key points that come through the middle, and you're showing the extreme high and the extreme low where they belong. The rest of it, I'm not going to actually have you always doing the pi/6 pieces. These are just for our initial looking at it so you can see the shape. I'll be looking to see that the shape is okay. Now these will be certain things that I am going to have to figure out a submission way where you'll be emailing me some of your graphs, because I just can't get around looking at what you have made for these, because that's important. But I'll be giving you special instructions for the subject header so that I can have them all dumped into one file rather than randomly all over my inbox. It's been challenging to say the least, but we'll get this all down. But it is going to be important that you're able to make a good graph with that, going as high as it needs to go, going as low as it needs to go. And of course we're going to have some variations on this. This is why it's important to get our basic shape of a sine wave to go. First of all, and another thing is that it is continuous, which means that this graph is going to continue on and on and on. We can't draw forever, but this pattern just keeps going and going and going. There's no gaps, there's no holes, there's no asymptotes, nothing like that. Its x-intercepts are at multiples of pi, so that means where the zeros are at multiples of pi. So at 0 and pi and 2 pi and 3 pi and 4 pi and 5 pi, on and on and on and on, you have zeros. A complete cycle of all of the sine values happens over a period of 2 pi. And these periods are going to be important even when we get on to graphing the tangent and the cotangent and the secant and the cosecant, which is where we're heading. The period of an entire cycle of values is important when you're going to be able to make those. So this is what our sine curve looks like. It starts at 0, it goes up to 1, it goes back down to pi, it goes down to -1, and back up here at 0 at 2 pi. So you always are thinking your pattern for sine is middle, up, middle, down, middle. And I'll be repeating that kind of over and over and over again so that you can make sure that you're really owning that and doing well with it. We need to think about cosine. Now notice I made the chart a lot simpler. Even though we know that there's all these curvy values, and the cosine graph is going to look very similar to the sine graph, we need to recall the idea that if you're thinking of S as being your radian measure angle here, that the cosine values come from the x coordinates. Okay, so our cosine here would be 1. Our cosine here would be square root of 3 over 2. Our cosine here would be square root of 2 over 2. Our cosine here would be a half. And our cosine here would be 0, negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2, negative 1, and on and so on and so forth. But what I have here is I have important points for us to consider as we're going around and thinking about a period. Now the period once again is from 0 to 2 pi because you'll hit all of those cosine values as you go around just one time. So I really wouldn't need these two, but I left them there to kind of show that we can repeat our pattern. So I want to look at 0. At 0, the cosine value is 1. So you would write in a 1. Okay, I'm not sure if this is going to work. It is. If you go to pi over 2, the cosine value is 0. If you go to pi, the cosine value is negative 1. If you go to 3 pi over 2, the cosine value is 0. And then so on and so forth. When you get to 2 pi, that's all the way back here, and we're back to 1 again. We've gone through a complete cycle. This is our complete period. But 5 pi over 2 would be just going another half pi. So we would get back to 0. And then 3 pi would be over here, negative 1. So you can see that repeating pattern come out. So the similar thing was happening with sine. But we have different values now. 1, 0, negative 1, 0, 1, 0, negative 1. So when you graph it, once again, you're going to need to make sure that you go as high as 1 and as low as negative 1, and the places where 0 lives are important. So what you would end up doing, and I'll just kind of let you see it happen here, if we have our x-axis and we have our y-axis, x-axis and y-axis, and you don't need any kind of special graph paper for that. You might have put those on, but you've got lines on a piece of lined notebook paper, and that's fine. And so you might have, if you have a line up here and you have a line below here, okay, so you've got you have your x-axis. Now your x-axis is going to be your pi values. So in our chart we had 0, 1/2 pi, pi, 3 pi over 2, 2 pi, 3 pi. I'm just going to put those values on it real quick. And this is what you would do, is I would actually probably start with pi and 2 pi and then divide those up. And 3 pi. And then I'll divide this up into pi over 2, which is a half, and 3 pi over 2, and 5 pi over 2. And I'm looking for neat. Make sure that, at least they're approximately spaced out correctly, so that you're getting a nice looking graph of pi. When you choose where 1 is and where negative 1 is, it's super important that you make your graph go all the way up. Now let's take a look at these values. Let me see if I can copy this and bring it along with us. We're going to copy. We'll see if it'll behave itself. Now we're going to paste. Nope, it didn't. It likes me to do things a slightly different way, so I'm going to do this, and you're not seeing what I'm doing, but we'll just do that and see if this helps a little bit better, because I'd like you to see this both in the same place. There we go. we're looking at our values here. And so at x equals 0, y equals 1, this is different than what happened on the sine graph. And at x equals pi over 2, y equals 0, these zeros are still super important. And then at pi we have negative 1, and at 3 pi over 2 we have 0, and at 2 pi we have that, and 5 pi over 2, it's all over 2, not just part of it, 5 pi over 2, and then 3 pi goes back down here to negative 1. One complete cycle, we said, goes from here all the way down through pi over 2. It's very hard to draw like this, so back up here through here. Notice that I'm really, really careful not to make a point at the top, at the bottom, because it is a curve. It goes down through here, and it would continue on, because remember it's periodic, so it continues on and goes forever and ever and ever. One complete period, though, is going right from here to here. 0 to 2 pi is one complete period. So what we see when we look at this graph, one complete period being from here to here, is that our zeros are now at pi over 2 and 3 pi over 2. And we have an up. So our pattern for a cosine is up, middle, down, middle, up. So you're thinking about it as a pattern that goes on and on. Up, middle, down, middle, up, middle, down, middle, up. And going on and on and on. So for those of you that think in patterns, that's what you're doing. And then you're sketching in the curve that goes with all of those other points. All right, so it goes on and on forever. We're going to discuss all of the facts. Our domain, once again, it goes on and on forever. So negative infinity to infinity. The range is still negative 1 to 1. It is still continuous over the entire domain, and its period is still 2 pi. It is symmetric around the y-axis, which means that if you make this the dividing line, it will flip over the y-axis. The sine function is not symmetric around the y-axis, because you flip it over, you wouldn't have the same thing. The x-intercepts are the odd multiples of pi over 2. So 3 pi over 2, 3 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Technically, the way you would write that would be 2n plus 1 times pi over 2. But if you're just thinking about those odd multiples, think about going around the unit circle. It's where you hit up and you hit down. Those are where the zeros would end up being. So we have this, and our basic pattern is up, middle, down, middle, up. And you're going to be thinking about that as you go through and you make all of the graphs for them. All right, on the calculator, if you want to see that and you want to see the trig functions, you are going to use Zoom 7. So just as a really quick thing, if you hit y equals and you push, I want to put it into radians, make sure my radians are on, okay. And I want to push y equals, and I want to see the sine of x, and you want to see the graph. We're going to zoom this time, but it would be Zoom 7. That's the trig graph, so we want to see that. And the way that they'll work that out, okay, they work that out, so this is pi, and sorry, this is 0, this is pi, this is 2 pi, 0, pi, 2 pi. One complete cycle, and they actually go a second complete cycle into the negative zone. If I want to look at the cosine, and I will zoom 7 it again, hit enter, and it's coming up like this. Here's our cosine, and once again it's in trig, so that means that our little dashes here are a 0 and pi over 2 and pi and 3 pi over 2 and 2 pi. So here is our complete cycle with that. So our up and our down are at 0 and pi and 2 pi, just like that. So you can use the calculator to help you see, and then these little dashes are the half pi marks. Okay, that's helpful to you a little bit, but when we start moving them around, you're going to need to have more resources from that. But there's something so you can check your work. All right, so what we need to do is we need to think about when the graph gets higher or gets lower. So in other words, when the range of values becomes more than just 1 to -1, but it stretches out in a vertical way. That is when you multiply something times the sine or the cosine, you'll have the same basic pattern except it'll stretch it out. So for example, if I want to look at the graph of 2 sine of x, that means that every one of the values gets multiplied by 2. What that means for you is that you're not going to be going from 1 to -1 anymore. You'll be going from 2 to -2. 0 times 2 is all just 0. So these key points, now these are super important key points. Whenever you're graphing a single period for any of these trig functions, I'm going to expect that you have 5 key points. I'm going to expect that you have the beginning, the middle, the end, and then the 2 that are between the beginning, middle, and end. So I'm going to be looking for 5 specific graph points and then a nice curvy curve that goes and bounces between them. We changed them to 2 and -2 because this 2 multiplies the original one. Sine of x, sine of pi over 2 is regular 1, but we multiply that by 2 and get 2. Same here with our -2. So when we graph it, it looks the same. The zeros are still at 0 and pi and 2 pi. But this value goes up to 2 and down to -2. And even though my curve is not perfect, I made it a very strong point to not make it up to points. Okay, these are curves, and it should be as smooth of a curve as you can draw. I kind of left my imperfect drawing there to show you that I'm looking for pretty good so that you're showing how this goes. When we take 3 cosine x, what really happens is the places where it would have been 1 get extended to 3 and to -3. So my basic cosine graph begins to look like this. Remember I said the pattern was up, middle, down, middle, up. That's going to always be the case for our cosine curve. Up, middle, down, middle, up, from wherever your period starts to where the period ends, 0 to 2 pi. But our up and our down has changed because we have now a multiplier. You have a 3 as being your amplitude, we call that. In other words, how high or how low it goes. So make sure you get your mind around that. The only thing that changed is it stretched up and it stretched down. Now, we have another thing that happens. Sometimes you'll have a number multiplied that's inside, basically that it's multiplied in here. And what that's going to do is that's going to effectively change the period. And it's going to change where your x-intercepts would be. So this is where it gets to be a little tricky, but you can handle this. Our original range for a sine function is 0 to 2 pi. That means that bx, whatever it is that's multiplied times b, is now in place of this regular x. so that our range for a normal one would be 0 to 2 pi, but I have this bx value in this spot. So we'll put that between. And then when we solve this inequality and we divide all three places by b, what that gives us is our new period. Now it doesn't go from 0 to pi to 2 pi, it goes from 0 to 2 pi over b. And just to make that clearer, of course, we have examples. So y equals the sine of 2x. We want to put 2x in between 0 to 2 pi, which would be our standard range for a sine function. I want to divide all those by 2, because when I divide them by 2, I end up with x by itself in the middle, so my new range of values is 0 to pi. Now, if we want to make a good sine curve, we need to graph 5 points. We need to graph the places where 0 happens, and that will be our 0 and our pi. Another place where a 0 happens will be exactly in the center of that. So the second thing I need to do is I need to figure out what's exactly halfway between 0 and pi. And we're thinking fractions here, so halfway between 0 and 1 is 1/2. After you're thinking about what's exactly halfway between 0 and pi, you add the start and end and multiply by 1/2. That'll be our middle. But then you need to find the middle of the middle between 0 and the middle. So you need to add 0 and 1/2, multiply times 1/2, which would give you 1/4. 1/2 plus 1 times 1/2 would give you 3/4. If you are not great with fractions, you can still do that on your calculator. Don't forget about your math frac button. But once again, you're finding half of the beginning of the end to get the middle, and then half of the sum of these two and half of the sum of these two. You're finding the averages so that you're getting a nice even distribution here. It still goes up to 1 and down to -1 because there's no multiplier here. And then you follow the pattern for sine, which means you go middle, up, middle, down, middle. These three spots are the places that get the zeros. And then there's an up and there's a down. So you can always start. Your safest thing is to mark where you know you have the zeros, which is start, middle, end. And then after you've got the start, middle, end, you say, okay, well, sine goes up first and it goes down. So you've got an up and a down, and then after you have those 5 points, you just sketch in your curve very, very nicely. So it's not as hard as you might think. You have to figure out your range of values, just figuring out 5 fractions with a pi after it. And then you go up as high as you need to and down as low as you need to, and you've got a very nice sine curve, very easily drawn. All the sine graphs represent the same pattern. Okay, so let's take a look at another one. We're going to look now at cosine graph. All the cosine graphs follow the same pattern. Remember, our basic cosine graph starts up, goes down, and then comes back up. So all of the cosine graphs are going to follow that same pattern. We're going to do the same thing. The period of a normal cosine is 0 to 2 pi, so we're going to start by putting that between 0 and 2 pi to determine the period. We need to get x alone, so you might remember that in order to do that, multiply times the reciprocal. We will multiply 3 over 2 times each one of these pieces. So 3 pi over 2 times 0 is 0. 3 pi over 2 times, or 3 halves times 2/3 gives you 1. And 3 over 2 times 2 gives you 3 pi, because they cancel out. So our period for this one is 0 to 3 pi. We then need to find, we've got the beginning, we've got the end, we need to find the middle. So you would take 0 plus 3, which would give you 3, times a half. So your middle would be 3 halves. To find this one, you take 0 plus 3 halves times a half, which would give you 3/4. To find this one, I'm taking 3 halves plus 3 times a half, which gives me 9/4. Once again, you are savvy with the calculators. You are certainly welcome to do that, but make sure that these are fractions in terms of pi. We don't mix fractions and decimals, or we don't mix decimals and pi. You've got to have fractions and pi for these things. So we've got, you're always looking for the 5 key points, the beginning and the end, which we find by doing this. Then you're doing a series of add and divide by 2 to get the middle, add and divide by 2 to get that. So now that you have them, the basic cosine pattern is 1, 0, -1, 0, 1. We don't have any multipliers, so the 1s all stay 1s, the 0s stay 0s. And when you are putting in your graph and you're putting in your pi and your 2 pi and your 3 pi, okay, what we want is, we really want these key points. So really our 2 important ones to place would be 0 and 3 pi first, then a little mark directly, completely 100% between them, and mark that 3 pi over 2. Then a mark that's directly between them, which is 3 pi over 4, directly between them, which is 9 pi over 4. The only reason I have pi and 2 pi in here is so for context, so that you can see where they are in relation to those numbers. But our key points are 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, and 3 pi. So we start at 1 and 0 and -1 and 0 and 1, and you follow that pattern. 1, 0, -1, 0, and 1, and then make your curvy loop right in there. So these do not have to be the hardest thing in the world to do, but it is something that's brand new for you to learn, but I'm confident that you're going to be able to get it. All right, now we've got a better thing. This part right here is going to help us determine the period. This part right here determines the amplitude, so how far it bounces up and how far it bounces down. So of course you can combine those two things. So let's take a look at this particular graph, and we've got a negative thrown in here too, because isn't that special? We may as well make it have to do everything. So what you do first is you want to deal with how big your period is. So we put that between 0 and 2 pi. But we also want to consider also the range. Okay, first of all, okay. So we can talk about this number first of all. Let's do that. The negative tells us, instead of starting up, or starting at starting 0 and then going up, we're going to 0 and go down, because the negative flips it over. So instead of like a normal sine curve, we'd go up and then down. For this reverse sine curve, we go down and then up. Same pattern. This 2 tells us that instead of going from -1 to 1, we're going to be going from -2 to 2. This should be a bracket instead of a parenthesis right here. And it's not going to let me fix it, but that's okay. It's a bracket instead of a parenthesis. This part is the part that's going to tell us our range. So between 0 and 2 pi, you put the 3x, and then you have to divide all three places by 0 and by 3 so that you get 0. And you're finding out the places where you're going to have a 0. You'll have a 0 at 0 and a 0 at 2 pi over 3. Then you have to find the middle by doing 0 plus 2/3 times a half. Let's think for a minute, just so we have that. If we take, I want you to see this happening. We said we had 0 and 2 pi over 3, I believe. Let's double check that. Yep, 0 and 2 pi over 3, or 2/3 pi. So I want to find this middle one, and I'm going to do that by taking 0 plus 2/3 times a half, which is 1/2 of 2/3, which is 1/3. 1/3 is really just 1 pi over 3. I need to find this one, and this one I do by taking 1/2 times 0 plus 1/3, and that would give me 1/6. Usually this one's a little bit easier to find, so we'll just put a pi in there. Over here we're taking pi, or we're taking 1/3 plus 2/3 and multiplying that times a half. Let me get rid of this mess. So 1/3 and 2/3 is 3/3. 3/3 is just 1. So this one's pi over 2. So once again, these are evenly spaced, so when you're trying to space that out for a graph, all you're going to need to do is, if you put the 0 for the beginning and the 2/3 for the end, you mark your middle, for your middle, and then I'll just expect you to put the correct labels in. We're going from 2 to -2 because of this change. For sines, you're always starting at 0, so my 0 points are here and here and here. So if we're going to put in those dots, we would put in here and here and here. Normally we would go up and then down, but because of the negative, we go down and then up. And then you make your very nice curvy curve that goes in there, and we've got one period for the sine of -2 times the sine of 3x. And that would be your graph. Okay, we are approaching, or getting closer and closer. This is just more of the same, because you're always going to be finding the range, figuring out what this is telling you about stretching it, and then going on from there. Okay, so this one, if I have 3 cosine pi x, this one's just kind of a little wacky. Hopefully you're saying, okay, I know that this is going to stretch it up 3 and down 3. And then this one I need to put between 0 and 2 pi. Okay, so my amplitude is 3. This goes between 0 and 2 pi. We can divide everything by pi here. This is one of the few where we don't even have pi in your answer. You have between 0 and 2. You would then do 0 plus 2 divided by 2, which would give you a 1. So that would be your middle. 0 plus 1 times a half, it gives you a half. 1 plus 2 times a half gives you 3/2. So once again, putting your key points in your graph, I'm going to be wanting to go up 3. I'm going to be wanting to go down 3. This is your just normal standard piece of notebook paper that will help you with that. I want my key points. I want my 0, my 1, my 2, my 1/2, my 3/2. So you would put 0, you would find a place to mark a 2, go halfway and make a half, 1, then a half, and then 3/2 for those spots. Our cosine pattern is up, middle, down, middle, up. This is kind of a tall, skinny one, which makes it a little bit difficult to make. But up, middle, down, middle, up. Because your general pattern, remember your general pattern for cosine graph is starts at 1. It's at 1. It's not working. General pattern for a cosine graph is 1, 0, -1, 0, 1. So when we multiply them by 3, we get 3, 0, -3, 0, 3. And that's what came out on these graphs. You could take the same thing if you wanted to, and you could say, all right, well, what if instead of this it said -3 cosine of pi x? Well, this would be the exact same thing, except it would turn the whole thing upside down. So rather than starting up here and going down, you would start down and you would go up. So at -3, a half, +3, 3/2 would give you the other 0, and then down. Sometimes people will accidentally skip the stop at the zeros. Be careful of that. Remember, this does go on and on and on. It is periodic. So another thing that sometimes I see people do is confuse this with a parabola and want to keep it going down this way. It doesn't. Notice that I on purpose made the little curve to show that it would go on this way if it was going to go on. Make sure that you distinguish between a parabola and this, because it's definitely not a parabola. This one cycles back up. All right, we are almost there. This is an example from your book, just paraphrased. They have a place called Mold Bay, Canada, and maybe one of our students knows where that is. But the average temperature of degrees Fahrenheit in Mold Bay is approximated by this function, and this is a useful thing in it. You do not need to know this, but it's just an idea to show you that you can have a situation where somebody figured something out that is based on that. Temperature would be periodic because it's something that, like, every year you have a pattern, and so people who are predicting the weather can use these patterns that they find that do kind of remind you of possibly the temperature is going up and then the temperature is going down and kind of equalizing in the middle. And they notice that in this place it follows this particular pattern. We want to just take a look at that. If it says the average temperature in November and x equals the month number, November is the 11th month. So to use this formula, all you would do would be to plug it into a calculator. 34 times sine pi over 6 times, watch your parentheses, you got a beginning parenthesis and an end parenthesis. And so in Mold Bay, this tells us that we have about -12.2 degrees Fahrenheit. Now be careful, because degrees as in temperature degrees is different than degrees as in trigonometric degrees. Make sure that your calculator is set to radians for this. All right, so finally, I'm ready to wrap this up. And congratulations, you made it to the end. I hope that you have a wonderful, blessed day. And I hope to see you soon.